Hello, you HL folks. I was hoping to talk to you today live, but you have not joined me, but that's okay. I'm going to give you a series of little videos here to watch, which will be just as exciting. So there's a couple of things for Trig, for HL, that you need to know. And I sent you some things to read in Canopy, as well as some questions to work on. It's quite a few, but some of them are really fast. Some of them are a lot more challenging. Be a bit of a mixed thing there, and perhaps you'll tune in next week and ask me some questions about that. So if you look in your formula booklet, there's actually very little as far as trig goes that you need to know that's written there, but there's a few little ideas here. So the first one is that when we're measuring angles, most of the time we use degrees, but for HL, we're going to use radian measure. And so you have to be able to go between both of those. And just a reminder here for that, check your calculators when you're doing trig to know if you're in radians or degrees, because you'll be switching back and forth. Why radians? Because it carries no units. 360 degrees has a unit. Radians, we say radians, but it's not actually a unit. Let me describe why. So if we look at an angle, let's say this is an angle here, theta, okay? And it could be any angle. I can rotate it as much as I want on a circle. Yes, that is a circle. Okay, now usually we would say, I don't know, that's like 50 degrees or something, whatever it is. That's fine. But it's arbitrary. We split up a circle in 360 little slices, pi slices. Arbitrary. It doesn't have to be that. So how can we make it a little better? The way we do it is we ask ourselves, what is the distance that I travel along here? That's called the arc length, which we'll use as L, okay? You will always travel a certain distance there. And what is the ratio between that distance and your radius, r? So what I'm talking about here is arc length divided by the radius. That will actually be what's called my radian measure, because that will be unique to any given angle. And it will be the same because no matter how big your circle is, because it's a ratio. So the bigger the circle, yes, it'll be a bigger arc length, L, but it'll also be a bigger radius. And that'll hold steady. So that'll be the radian measure. Okay, now I just wrote a formula there, but it's actually only true for radians. Radian angle, if you want. It's not, it won't give you degrees, okay? Now, is that in your formula booklet? Indeed it is. They just rewrite it like this. And it is right here. And they do tell you it's in radians. A warning, okay? Because I can find the arc length. If I know the angle and the radius, I can find the arc length. But it works either way. So that is the radian measure. Now, the only thing you need to really do, and to be kind of familiar with that, besides knowing that formula, is what the conversion rate is. So the conversion rate, 360 degrees, is equivalent in radian measure to 2 pi. Because what's a full circle? What's the arc length of a full circle? It's the circumference, 2 pi r, divided by the radius, r. So full circle, right? The radian measure would be 2 pi r, that would be the arc length, divided by the radius. So a full 360 rotation is 2 pi. So that's your conversion rate. Or if you want to simplify it a little bit, pi, okay, is 180 degrees. So if I say sine pi, it's the same as saying sine of 180 degrees. Notice there's no units on pi. Pi is not the unit. Pi is 3.14159, et cetera, et cetera, et cetera. Okay? So if ever you want to convert, the way you can set it up is like this. You can do a little ratio. So this is the same as your radian measure divided by your degrees. And you can do that conversion. Or vice versa, you can flip it, it doesn't matter. Okay? So you can do this, although that's not a formula in your formula booklet, you need to be able to do that. Okay, last thing, so that's your little formula for arc length, is area of sector. So if you wanted to know what the area of a sector was, so I'm talking about this, right? Usually we just do a ratio, but of a full circle. So usually we do a full circle is pi r squared. That's the area of a full circle. And you want to know your area. That would be equal to the same ratio as your full angle for a full circle, which is in this case 2 pi, if we're talking radians, right? That's a full circle, divided by your angle. Now I can simplify, and I can say, well, the area, if I cross multiply, will be equal to 1/2 r squared theta. And that is indeed the formula that you're given here for exciting effect. I will color it in. There you go, it's right there. Okay, so if you see those, it's in radians. Just make sure you know not to use these formulas in anything else except in radians, okay? That's where they come from. So you can get the arc length or the area of a circle or part of a circle with these formulas as long as you're in radians, and make sure you know how to convert radians to degrees, okay? You guys are pros, so you'll be working more in radians than anything else. It's just degrees we use to talk to normal people that aren't HL. Okay? So that's part 1. That's it.